Hi engineers, today in this lecture we are going to see about the Nichols prism. William Nicol invented the optical device which is used for producing plain polarized light. So from unpolarized light we will get the plain polarized light. Now we will see how the Nichols prism is designed and how it will work. So when come to the principle, this will work on double refraction. So what is double refraction? As we know, whenever the light rays pass through the some type of the crystals, it will split into two rays as a ordinary ray and extraordinary ray. One beam we will block it and only allow the one beam to come out. So whatever the beam come out, it is a plain polarized light we will get. So in Nicol, ordinary ray is eliminated by total internal reflection and extraordinary ray is transmitted to the crystal which is plain polarized. So what do you mean by total internal reflection? Whenever the light rays travel from denser medium to rarer medium at the boundary, if the angle of incidence is more than the critical angle, the light ray traces back into the same medium. That's what we call total internal reflection. So these two principles we will use. One is total internal reflection, another one is a double refraction. So we will use these two principles in order to get the plain polarized light. When come to the construction, this is made with calcite crystal. So basically the calcite crystal we will take, which is length is 3 times as its width is taken. So that is a 3:1 type. Initially it has an angle of 71. Then what we will do is we will cut with 68 degrees and parallelly we will cut here and we will polish these two surfaces, A prime and D, B and C prime. Now we will cut this crystal along the diagonal A prime C and we will polish it, and Canada blossom we will use and we will stick it again. Now we will send a light ray through it. Whenever the light rays pass through it, it will get into two types. One is extraordinary ray, another one is a ordinary ray. What happens next? Whenever we are using a Canada balsam here for the joining the crystal, this will make a difference in a refractive index and makes that ordinary ray to get reflected here itself, so that it will get total internal reflection and this extraordinary ray passes throughout. We are taking a sodium lamp. That sodium lamp, for sodium the refractive indices are 1.66, 1.55, 1.49. Ordinary ray, Canada balsam and extraordinary ray. So whenever we take that, due to this refractive indices, there will takes a total internal reflection by ordinary ray, and one side we will coat with the lamp black and that ordinary ray will be absorbed, and extraordinary ray transmit from Canada balsam layer is plain polarized. In this way Nichols prism act as a polarizer, so it will produce a polarized light. Now in order to identify whether the light is polarized or not, same another Nichols prism we have to take. So whenever we keep the two Nichols prism parallel to each other, then extraordinary ray passes through both Nichols prism. We can see here in image A. In the second case, if we rotate it, this will get different and that ordinary ray will get, it won't pass through it, it will gain. When the second Nicol is gradually rotated, then intensity E ray decreases. If N1 and N2 are perpendicular to each other, then no light come out of the second Nicol prism. Here we can see no light is coming out. Further N2 is rotated, the intensity of emergent light increases. This way we can say that Nicol prism act as a analyzer. So Nicol prism can be act as a polarizer as well as a analyzer. Then these polarizers has many applications as we discussed previously in liquid crystal displays, photography, microscopy and many scientific and medical purposes we can use polarization. All the best for your future. Goodbye.